So just moving on here in part 2, we were just saying that dipole attractions amongst the carbonyl group. So this was your carbonyl group in here. Because that's polar and because they're all attracted to each other, like they are here, you can see the dipole forces in there. That's quite hard to break. In fact, you need a lot of energy to break those up. And what happens when you break these? Well, when you break these bonds, you're talking about changing the state. You're talking about a boiling point. When you boil something, you're turning it from a liquid into a gas. So if we have a look at two compounds here, and this is the way it's often worded in leave insert, the dipole-dipole attraction creates a higher boiling point than the corresponding alkane. Corresponding alkane means an alkane with the same number of carbons. And if we look at the two compounds here, we've got ethane, which is an alkane with 2 carbons. We've ethanal, which is an aldehyde with 2 carbons. The boiling point of ethane here is around minus 88 degrees Celsius. That's the boiling point, so that's when it turns into a gas. Whereas ethanol, the boiling point, is in around 20 degrees Celsius. So this has a much higher boiling point. And the reason for that is because of the carbonyl group, which is polar, and you need to talk about both of those. So on to the next part of the physical properties. If before we move on, we just have a look at one more compound, which would be methanal, which would be C double bond OH, with just a hydrogen on the end. There's only 1 carbon. This is methanal. The boiling point of methanal is actually in the negative figures. It's around minus 19 degrees Celsius. So often what they'll do is they'll talk about room temperature. So at room temperature, which again is around 20 degrees Celsius for us, methanol would be a gas because it will have boiled. Ethanol would be a liquid. And in general, the rest of the aldehydes that we're looking at would also be liquids. So if you continue on to propanol, and you continue on to butanol, and so on and so forth, these are all liquids. So that's boiling point discussed. The second one that we're going to have a look at is solubility. And we have to look at these for all these organic compounds. So we've looked at 1, boiling points. That's the first physical property we've looked at. Now we're going to move on to 2, which is solubility. So generally we test solubility in 2 compounds. We look at it in water and then we look at it in other organic compounds. So let's start with the solubility of water. So lower aldehydes, so we're talking about meth and eth. Lower aldehydes are highly soluble in water. And one of the main reasons for this is this carbonyl group. So if you look at the carbonyl group where the carbon is slightly positive, the oxygen is slightly negative, and then you take a water molecule, you've got a water molecule which will be shaped like this, H2O. The water molecule is a polar molecule as well, and at this end is slightly negative by 2, and this is slightly positive. Again, we'll look at polarity again at a later point. So again, this oxygen is attracted to this hydrogen because opposites attract. The same thing would apply over here. You would have another carbonyl group on this side, where this is slightly positive and this is slightly negative. In these particular circumstances, this here is what's called hydrogen bonding. Now don't worry too much about that, we haven't gone through that in much detail. So hydrogen bonding exists there, and it exists there, between the water molecule and the carbonyl groups. And it's this hydrogen bonding that causes aldehydes to be very soluble in water. Now, the longer the chains, so for example, this is for lower aldehydes. So you're talking about 1 carbon, 2 carbons, 3 carbons. If you move up to 5 carbons and 6 carbons in the aldehydes, they become less soluble. So higher aldehydes are less soluble in water. And then the last solubility, so that's for water. The last solubility then that you have to know is organic solvents. So they are highly soluble in some, but generally soluble in organic solvents. And the organic solvent that we often talk about is methylbenzene. Okay, so that revises over the aldehyde family. So if we have a look at it very quickly, you had your functional group, you have your names, methanol, ethanol, propanol, butanol. You had the isomer of butanol, which was 2-methylpropanol. You have benzaldehyde, which as an example, and then 3 uses, or 3 places that it's found. Physical properties. So again, physical properties, boiling point is the first one that we looked at. So we looked at the carbonyl groups. Now again, we won't be going through that in the next family, but at least you know what a carbonyl group is now. So we looked at the boiling points of aldehydes and why they have a high boiling point. And then secondly, we looked at solubility. So solubility in water is the first thing you need to know. And the other solubility is in organic solvents. So solubility in water and solubility in organic solvents. And you'll need to be able to look at that for all the other families as well. So that pretty much covers aldehydes. It's finished. We move on to ketones next, which is very, very similar to aldehydes. Let's have a look at it.